Hello everyone, welcome to Easy Chemistry by Praveen. So today we are going to discuss about the topic is called as a law of gaseous volume. What is meant by law of gaseous volume? This was introduced by the scientist Mr. Gale. So here you can see that according to this law, gases are reacting with each other in a simple whole ratio of their volume. If product also gases, they are also simple ratio in a volume. All the volumes are measured at a constant temperature and pressure. So to understand the new word, temperature and pressures are the similar. That means temperature and pressures are the constant. So that time this law is applicable. We know that volume is directly proportional to the number of the moles. So to understand this law, we can take the one equation. So let us take it. H2 plus Cl2 gives rise to HCl. So to apply this volume, to calculate the volume of the reactant and product, we have to do the balance the equation. That is the word. So you can see that H2 plus Cl2 gives rise to the 2Cl. So after balancing of the equation, so here L1, here so here, this is the stoichiometric coefficient. This stoichiometric coefficient, while calculating the volumes of the gases, you can consider it as a volume. Stoichiometric coefficient, consider it as a volume you can consider. So you can see that is only we have in the volume analysis. So volume analysis. You see volume analysis, you can consider the stoichiometric coefficient as a one volume. So here you can see one volume of H2 is reacting with the one volume of CO2, producing the two volumes of HCl gas. If you take it as a 1 ml, it is also 1 ml, it is producing the 2 ml. So you can do with the volume ratio or unitary method also we can do. So we will discuss about the two or more numerical based on that also. So for example, if you take it is 1 liter, it is also 1 liter, same. So it is producing the 2 liter. For example, H2 is x liter, this is also x liter, it is producing the 2x liters, it is producing. So now you can see the one numerical. So you can see how we can apply the law of gaseous volume in this equation. First of all, we have to balance the equation. So N2 plus 3H2 gives rise to the 200. This is the 1. So you can consider this stoichiometric coefficient as a volume you can consider. So you can see that one volume of nitrogen is reacting with the 3 volume of the H2. So how much it is producing? You can consider unitary method. So it is producing the 2 volumes of NH3 is producing. 2 volumes of the NH3 is producing. So let us take one hypothetical question. So here all our reactant or products are in the gases. So consider the coefficients as a volume. That means this is A volume, this is B volume, this is C volume, this is small d volume. Okay. You can consider the coefficient as a volume you can consider. So, suppose volume they have given, reactant volume they have given, they are asking the product volume. How can we do? So, for example, they have given the volume of this reactant. They have given the volume of this reactant volume is VA volume they have given. They have given the VB volume they have given. So VC volume they didn't give. We have to calculate. They didn't give the VD volume. That means reactant volume they have given. We have to calculate it. The product volume we have to calculate. So in this time you can go with the volume ratio you can go. So already we have discussed the volume analysis. So let us say. So stoichiometric coefficient is there. No, you can consider it as a volume. You can consider. So whenever we are doing the volume ratio, whatever the volume they have given upon the coefficient, or moles you can take. Now we are dealing with the gases, that's why I am taking the stoichiometric coefficient as a volume. So now we can take it as a VA by A is equal VB by B is equal VC by C is equal VD by D. Like this we can consider when it is applicable. That means VA by A is equal B. That means both the reactants are completely consumed here. You can see that if you use this equation, if you equate the equation, when it will be useful in the sense VA by A is equal VB by B. This means what? Both are equal. This means both are completely reacting in a reaction. Both are completely reacting. So you can say that A and B are completely reacting with each other. Reacting with each other. This is the time. That time we can equate the product and reactant we can easily get. But all times it is not. So some cases you can see the case 2. For example, volume ratio, you are doing the volume ratio, but you have got the value like this. VA is not equal to the VB by B. That means what? VA by A. For example, for suppose VA is high. For suppose VA is the highest one. That means what? This is the limiting reagent. This is the excess reagent. So whenever the given reactions, the limiting reagent will control the reactions. So that time it will VB by, we can equate the VB by B with, if you want to calculate the volume of VC, one time we can divide the volume of VC, one time we can divide the volume of D. So then easily we can find the answers. So for example, case 3 you can see that VA by A is not equal to VB by B. That means we suppose VA by A, VB by B is greater. So that time what will happen? This is the LR, limiting reagent, this is the ER, excess reagent. So now, who is controlling the reactions? VA is the one who is controlling the reactions controlling. So now you can see the VA by A, one time you can equate with the VC by C, one time you can equate with the VD by D you can equate. So like this you can equate and you can do the calculation. Let us take one example. See the equation, SO2 plus O2 gives rise to SO3. So this they have given 10 liters, have given 50 liters, asking there what is the volume of SO3. So first of all, if you want to do this type of question, first step what we have to do is balance the equation. So after balancing the equation, go with the volume ratio. Volume ratio in the sense. So obviously SO2 is the limiting reagent. From this data we confirm that SO2 is the limiting reagent. So SO2 will control the reaction. So volume of SO2 upon the coefficient is equal to volume of SO3 upon the 2. Volume of SO2 we know that 10 liters upon the 2 is equal to volume of SO3 upon the 2. So 10 get cancelled. VSO3 volume is 10 liters. You can go with this method or you can go with the unitary method. How unitary method? So for example, unitary method you can see from this equation 2SO2 plus 1O2 gives rise to 2SO3. So 2, 1, 2. You can see the ratio 2, 1. That means if it is reacting with the 2 volumes, 2 liters volume, it is also producing the 2 liters volume. So it is reacting with the 10 liters volumes, it is 50 liters volumes. Of course, it is also produces the 10 liters volume. So this is, you can go with the unitary method, you can go with the volume ratio method also you can go. This one, gaseous alkane is exploded with the oxygen. The volume of O2 for complete combustion to the CO2 form is in the ratio of 7:4. Deduces the molecular formula of alkane. So they are asking about the molecular formula of the alkane and O2 CO2 ratio they have given. So first of all we have to know the molecular formula of the alkane, general molecular formula. So you can see that general molecular formula of alkane. So alkane is CnH2n plus 2. Okay, CnH2n plus 2. What they are asking? When CnH2n plus 2 is exploded with the oxygen, obviously it will produce the CO2 plus H2O, they will produce. So of course they have given the O2 and CO2 ratio they have given, they are asking the N value we have to calculate it. If you calculated the N value easily, we can get the molecular formula we can get. So now first of all we have to do the balance the equation we have to do. So here you can see n number of carbons. Here also n number of the carbons. You can see 2n plus 2 hydrogens are there. 2n plus 2 hydrogens. Here n plus 1 hydrogen. Why? Because here 2 hydrogens are there. 2n plus 2. Here also 2n plus 2. So now you can see here this side n plus 1 oxygen. No? Here n plus 1 oxygens and 2n oxygens. 2n oxygens. So that one 3n plus 1 oxygens. So we have to balance. So 3n plus 1 upon that 2. Why? Because 2 get cancelled. 3n plus oxygen. You can see 2n plus n plus 1 oxygen. Okay. So now what data they have provided? So they have provided the volume, the ratio, whatever the O2 and CO2 ratio, whatever is there, they provided that is also in the ratio of 7 by 4. So O2 by VCO2 is equal 7 by 4. We know that whatever the data is there, just we can keep put here automatically. So VO2, how much? Volume of O2 3n plus 1 upon the 2. VCO2 volume as stoichiometric coefficient considered as a volume, n volume. So now you can write like this 2n is equal 7 by 4. So 2 get cancelled. So if you do cross multiplication, so 6n plus 1, 6n plus 2 is equal 7n. So n is equal to the 2. We got the value n is equal to. Just substitute the n is equal to in this one. So you can get value Cn H2n plus 2. You can get C2H6. So alkane formula is C2H6. So in the question they have given 2 liters of CO and CO2 is passed over red hot charcoal. Its volume is increased by 1.4 times. If all volumes are measured at a similar pressure and condition, find out the final mixture they are asking, composition of the mixture. So see 2 liters of carbon monoxide and carbon dioxide mixture. Let us take this is x liter. This will become 2 minus x liter. So V final upon the V initial, it is increased to how much times? 1.4 times. So in the given picture, you have to understand is carbon dioxide react with the charcoal, it will produce the carbon monoxide. That you have to understand. So that means CO2 plus C, they will produce the CO, it will produce. So if you do the balance, 2, 1, 1. So you can see that here it is reacting with the x mole, x liters, it is producing the 2x liters it is produced. This means what? Final composition they are asking. Final composition in the sense CO is 2x liter. But in the given picture, it will also not react, no? CO2 only reacting, it will not react. This means final 2x by CO, this much of CO left and this much of CO is produced. So you can see that V final upon the V initial is equal 1.4 times. You do the so it is 2x plus 2 minus x upon the initial volume how much? 2 liters. 2 liters. How much it is increased? 1.4 times increase. If you do the simplification, x plus 2 by 2 is equal 1.4 times. So 1.4 times is the x plus 2 by 2 is equal 1.4 times. So x plus 2 is equal 2.8 times. So x is equal 0.8. So substitute this value. So carbon monoxide CO2 is how much? CO2 is 0.8. So carbon monoxide is how much? 0. It is 1.2 liters. So next class we will discuss about the atomic structures. We will discuss. So